All right, this is going to be AP Calculus Self-Check 3.2. I don't have a class, so I'm going to go through this a little bit faster than I normally would. All right, so let's talk about question number 1. All right, so here we have a graph of f prime. The derivative of the function f is shown, which is showing f decreasing. So f decreasing, what does that mean? I'm asking you that, so you need to remember f decreasing. F decreasing. The definition. This is the definition set in stone, and that is f prime is less than 0. Hopefully we got that. So this is the graph of f prime. So what represents f prime? Is it heights? Is it slopes? Is it concavity? If you responded with heights, that is correct. Remember, if it's a graph of f prime, heights is whatever this is equal to. If this is f prime, heights are f prime. So I'm asking, where is f prime? Where are the heights in this graph less than 0? Well, the heights are less than 0 between 0 and 2, because it's less than 0, it's a negative, and between 4 and 6. So what says between 0 and 2 and 4 and 6? E. All right. Number 2. The figure above shows the graph of the derivative. Again, we're given f prime. How many points of inflection? So inflection point, what is that? How many points of inflection does f have in the interval shown? Okay, so inflection point, what is the definition? The definition of inflection point. F double prime is going to change sign. All right, so where is f double prime on the graph of f prime? And again, it's the 3 possibilities. Is it height? Is it slopes? Is it concavity? So if I'm giving the graph of f prime, heights are f prime. That's the easiest thing to go for. So heights would be f prime. In order to go down to the next derivative, if I take the derivative of the derivative, it's a double derivative, or f double prime, heights, the next one down, is slope. And if I took the derivative again, I would get down to concavity. But we don't care about f triple prime, we don't care about jerks. So I'm talking about slope here. It always goes from heights to slope to concavity. It always goes from f prime, and then you go to another derivative, f double prime. So I'm asking, where is the slope here? Where does that change signs? So right here I have a slope that's positive and a slope that's negative, which means I have a slope change right here. Basically anywhere that I have a f prime equal to 0 or the slope is equal to 0, that's almost going to be exactly where I have an inflection point. Not always. This case, it was really close, but it's still an inflection point. A case where it's not an inflection point, where I have f prime equals 0, you might be saying, oh, that happens all the time, because look, f prime equals 0, I have a sign change. But look at this. So I come up here, and it comes out to 0, and then it keeps coming up. It never actually comes back down. This is a case where it's not an inflection point. So this is an inflection point because f double prime is equal to 0, or the slope here is 0, and it changes sign. Mainly, it changes sign. I know I'm kind of beating the dead horse now. So there's 1 here, 2, 3, and 4. There are 4 inflection points because it changes sign 4 times. All right, move it on number 3. So the graph of the derivative of f, so I'm given f prime, is shown above. Which of the following could be the graph of f? So going backwards. All right, let's analyze this. So I have f prime, the height is 0. Height is what? Is that f prime? Is that f double prime? What is height? Height is the same thing that I'm given. It's f prime. So the height here is 0, f prime is 0. F prime equals 0. Does that remind us of a definition? It should. That's a critical value. It's one of the 2 things that can give you a critical value. What's the second thing that can give you a critical value if the first thing is f prime equals 0? If you said f prime d and e, that is also a possibility, but we don't have any d and e's here. So we have f prime equals 0. We have f prime equals 0 here as well. So 2 critical values. So what can happen at a critical value? You can have a relative extrema. Again, what is the definition of relative extrema? Relative extrema is a f prime sign change. So it changes sign. So I have a negative, and then it comes up here and becomes a positive. It changed signs. So this is a relative extrema. Let's look at this critical value. Ooh, this goes from a positive to a positive, and I'll label that here too. A positive into a positive. That was not a good positive. I can rewrite that. A positive into a positive. There's no sign change. It stays positive and goes back to being positive even though it was a critical value. So that is not a relative extrema. So I need to have no relative extrema. I don't have any minimum or maximum on this part of the graph, but I do have a relative extrema over here. What is this? A minus to a plus, a negative to a positive, decreasing to increasing. What is that? If I'm decreasing to an increasing, that means I have a minimum. So over here, I have a minimum and no other extreme value over here. So let's see. I have a minimum here in A and D. I have no minimum in B, no minimum in C on the correct point. So it's between A, D, and E. Oh, this one has an extreme value over here. It can't be E. We discovered that it only has a relative extremum over on the left-hand side and not the right. All right, so in fact, there's no other relative extremum. So this right here is a max. That's a relative extremum. It can't be A either. There's only one relative extremum right here. You might say that looks like one, but it actually never has a slope of 0. So the correct answer here is D. Remember, relative extrema, minimum. This is a minimum. There's no other minimum or maximum on the graph. So which function has a minimum on the left-hand side of the x-axis and no other minimums or maximums? The answer is D. Moving on to number 4. The graph of f is shown in the figure above. Which of the following could be a graph of the derivative of f? All right, so this one is a little bit hard to see, but again, I'm given the graph of f prime. So I should label this f prime. So what I care about are the critical values. That's where f prime is 0. Height is f prime in this case. So height is 0 here and here. These are both critical values. And not only are they critical values, they are relative extremum. Again, what is the definition of relative extremum? Relative extremum. If you answered it's a sign change, you are correct. Sign change. It changed from a negative to a positive. It changed from a positive to a negative. All right, so what goes from a negative down here to a positive? Is that a minimum or a maximum? If you answered minimum, you're correct. And what goes from a positive f prime, remember height is positive, and then the height is negative over here. Height is f prime. Is that a minimum or a maximum? If you answered maximum, you're correct. So it has a minimum over here at this point and a maximum at this point. It's not at B, but a little bit before B. All right, so it looks like I have a maximum here and a minimum, so it can't be that one. Remember, it's minimum then maximum. All right, I have a minimum here, but that's not a maximum. That's another minimum. Can't be that one. I have a minimum here and a maximum. Ooh, it could be C. Let's look at D. It has no minimum right here. Can't be D. And E is just a linear function. So the correct answer here is C, just by analyzing the relative extremum. Moving on to question number 5 of 6. The function f has a property that f of x, f prime of x, and f double prime of x are all negative real values. Which of the following could be graphs of f? Okay, so what does f of x mean? So on the graph of f of x is heights, is it slopes, is it concavity? F of x. This is height. All right, so let's go through. All of them need to have a negative height. Negative height, negative height, negative height, negative height. Oh, you have positive height. Can't be you. All right. F prime of x, is that on a graph of f, is that going to be slope, height, concavity? What is this thing? If you answered with slope, you're correct. So I'll write that here, slope. So these all need to have a negative slope. So, oh, this is a positive slope, can't be A. That's a positive slope, can't be C. Negative slope, negative slope. Okay, so both of B and D all have negative slopes. Okay, and f double prime. On the graph of f, what is that going to look like? If you answered concavity, you're correct. Concavity. Where is it? Concave up, concave down. So it needs to be concave down for all values. Everywhere it needs to be concave down. Well, look at B. This is always concave down, but over here, this is concave up, and over here is concave down. And it needs to be always concave down, so it can't be D. Correct answer is B. All right. And moving on to our last problem, number 6. So the figure shows f prime, given the graph of f prime. It has 4 zeros, and we can kind of tell where they are. So there's 1, 2, 3, 4 zeros. It tells us 4 zeros. How many relative maxima here does f have? All right, maxima, definition. Maxima, what does that mean? That means where f prime changes from a positive to a negative. Remember, it was increasing, 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 and then decreasing. All right, since this is the graph of f prime, if I'm looking for f prime, is that height? Is that slope? Is that concavity? F prime is height, because this is the graph of f prime. The height is whatever this symbol right here is. This is f prime, height is f prime. So I'm looking where the height changes from a positive to a negative. Well, the height here changed from a negative to a positive, so that's not it. The height here changed from a positive, and didn't really change, it stayed a positive. The height here went from a positive to a negative. So I should do an arrow here. I should just say positive here, and it's negative down here. Ooh, so positive and negative. Ooh, that's one of them. So we'll maybe circle him in green. So that's one right there. And what about over here on the right? This changed from a negative to a positive. That's a definition of minimum, not a maximum. So we only have one maximum. So the correct answer here is 1. All right, that concludes all of the self-check 3.2. If you have questions, please ask me in class. And thank you for watching. Bye.